Okay, so this is solving complex number equation involve powers, because we have z to the power of 4. Anytime that you have complex number involve powers with complex number, that means you will have to use the de Moivre theorem. So that is the power that I'm talking about, and using the de Moivre theorem. Therefore, you'll have to use the r, because the de Moivre theorem, so you'll have to use the arg and the modular. So you'll have to rewrite the complex number from rectangular to polar form. So we'll start with the arg. Now, how would you find the arg in a complex number? K is a real constant. Therefore, that means this number here, the z to the power of 3, it's a negative real part only. There is no imaginary. So definitely the arg would be the anti-clockwise from the positive to the negative. So therefore the arg in here is pi. Okay, 180 degrees. That's how you find the arg. Okay, because just not imagining it, but this is negative real components only, real constant. So it's a real components. There is no I, and it's a negative in here. Therefore, it's pi. Anti-clockwise. Therefore, it's positive pi. So the arg for z to the power of 4 is equal to pi. And now the modular. The modular obviously is the length for that one here, from the 0 to there, and the length in this case is, it would be, remember the modular is the real component square plus the imaginary component square, all under the square root. But because here we don't have the imaginary components, so we only have the real components, so it will be negative 16k to the power of 8 all square, and all under the square root. This cancel out, but because of the square, so the negative disappear, and obviously there is no length negative. Therefore, the modular for z to the power of 4 is 16k to the power of 8. So if I want to write z to the power of 4 as a polar form, would be 16k to the power of 8 cis pi. Okay, so once you get that, then you will have to use the de Moivre theorem to find. So because we know that it will be 4 different solutions, so I would write this z1, z2, z3, z4. Now for that first solution, it will be the 4th root of all of that. So therefore, I'm going to write the 4th root of 16k to the power of 8. Okay, or I will actually find the 4th root of 16k to the power of 8, which is the modular on the side. So the 4th root of 16 is 2, and k to the power of 8 all to the power of a quarter will give me k square. So therefore my modular for each one of those solutions will be 2k square, 2k square, 2k square, and 2k square. And then I'll write cis, 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 and cis. And now all will have to be divided by 4 because it's the 4th root. And everything will be, the first is pi. Okay, so that's your original. And plus 2 pi times the different case, and that's what you get the 4 solutions from. So the different case, the first one is 0, and then I'll say pi plus 2 pi 1, pi plus 2 pi, negative 1, and pi plus 2 pi 2. Okay, and now fixing it, simplifying it. Square, and then fixing, that's pi times 0, so it's pi over 4 is your first solution, and this one times 1, so pi plus 2 pi is 3 pi, so it's 3 pi over 4. And you notice I'm writing it in pi, not in decimal. Okay, so you need to write in terms of pi. And this one, negative 1 times 2 pi is negative 2 pi. So pi minus 2, so it's negative pi over 4. And the other one is 4, so it's 5 pi over 4. You need to make sure that none of those solutions is more than 180 and no one is less than negative 180. So between 360 and negative 360. And that's it. So that's your solution for the merit level using the De Morbier theorem. Okay, so that's the solving complex number equations. But the first thing you notice in this question in here, as we said, this bit here, so it has powers, so you know straight away that you're going to use the De Morbier theorem. And because we're using the De Morbier theorem, therefore we will have to rewrite this complex number equation into a polar form. So first bit, you would rearrange, obviously. And then now you will find the arg and the modular. Now the args, it's good to draw that. So it's negative 16p squared. So I have imaginary negative. Doesn't matter how long is this at the moment, but it's imaginary negative. So this one would be here. Okay, so the arc, if you go clockwise, would be negative pi over 2, because clockwise from the real imaginary is negative angle or negative arc. Or you go anti-clockwise, and it will be 270, which is 3 pi over 2. Okay, so it's either clockwise will be negative pi over 2, or anti-clockwise it's 3 pi over 2, positive 3 pi over 2. So whatever you choose, I'm going to choose the 3 pi over 2. I'm just trying to say, like, you know, because you always know it's clockwise, it's anti-clockwise. So maybe if you remember that, then you will always take that angle. Now the modular is the length. So the length of that side obviously is 16p squared. 16p squared, not I, just the 16p squared, and it's not negative because there is no length in negative. Now I have the De Morbier theorem, so I'll end up with 4 solutions. So I'm going to write my solutions here. Z to the power of 4, that means I will have to take the 4th root to find Z. So the 4th root being quarter. So therefore I'm going to do 16p squared, which is the modulo, to the power of quarter. 16p squared to the power of quarter. I say in quarter and I'm writing half. Quarter, 1 over 4. P squared to the power of quarter, and 16p squared to the power of quarter. Okay, now cis. And obviously all to the divide by 4, because we have the 4th root is divided by 4. And because when the De Morbier theorem, you will multiply by the power. And because the power here is a quarter, so that's why we are dividing by 4. Now your angle, which is 3 pi over 2. 3 pi over 2. Look, I'm keep writing it the same. Plus, and now I will have 2 pi and then changing the k. So 2 pi 1, 0, and 2 pi negative 1, and then 2 pi negative, 2. Okay, don't need that bracket in here. Now, working it out, you can use that in the calculator. You can say 16 to the power of 1 ABC bottom 4. And that will give me 4. It's not 4. I think you need to put that in bracket because it's not 4, the answer 2. Okay, yeah, because you will have to put 16 and then the power, open bracket, 1 ABC bottom 4, close that bracket. So you'll have to put the power in bracket, and that's why we'll get 2. And then when you have power to power, you would simplify, and that's we'll end up with p to the power of half. And that's the same for all of them. So I'm just rewriting it for all of them. Now I'll put cis. And now I'll work it out. So this fraction here, you can work it out using your calculator, but you have to be very careful. So this is 2 pi times 0 is just 0. I don't put the fractions in the I don't put the pi in the fraction when I work on the calculator. So for example, if I want to work out 3 pi over 2 divided by 4, I will do 3 ABC button 2 divide by 4, and I get 3 over 8 pi. Okay, so I'll add the pi right at the end. And if I want to work out this one, I'll do 3 ABC button 2, that's for the second solution, plus 2 first. And I got 7 over 2, and then I'll do divide by 4, and I get 7 over 8 pi. Okay, so that's how you can use the calculator, but don't put the pi, because once you put the pi, then it won't change into decimal. And then the next one is again 3 ABC button 2 plus, minus this time, because it's negative 1, so minus 2, and then I will divide by 4, so I got negative 1 over 8 pi. And then the next one is 3 ABC button 2 plus 4 this time, and divide by 4, I'll end up 11 pi over 8. Okay, and that would be your solution. Remember, none of those solutions and angle will be more than 360 or less than negative 360.